Okay, this section is about simplifying radical expressions. Okay, so we have two rules. One is a product rule for radicals and the quotient rule for radicals. Okay, let's prove the first one. Okay, the nth root of u times v is, we can separate the factors in the radicand u and v, separate the u and v with the same nth root. So okay, let's prove. Okay, here's nth root of u times v. Then you can separate the factors u and v with the nth root. So nth root of u times nth root of v. Okay, well, how did we get this? Do you remember the previous section? Nth root. So we can convert this radical into an exponential form. So the radicand is uv. So we can raise this uv to the 1 over nth power, because this n goes to the denominator of the power. Okay, then this is equal to, assign the power to each factor in the base. So u to the 1 over n times v to the 1 over n. And back to, this is an exponential form. We can make this exponential form to the radical expression. So the denominator n in the exponent goes to the index nth root of u times nth root of v. So this is equal to the formula. Okay, how about the second one? Nth root of, the radicand is a fraction, it's a quotient fraction. Then you can separate the numerator and the denominator by with the same index n. So nth root of u over nth root of v. Okay, let's prove this one again. So we will use the same method. Put this index to the denominator of the exponent. So the radicand is u over v, and then we can make the power 1 over n. Then separate the exponent to each numerator and the denominator. So u to the 1 over n over v to the 1 over n. Then the numerator is, since the denominator of the exponent is n, we can make it nth root. Nth root of u over the denominator same as nth root of v. So if the radicand is a product or quotient, you can separate each variable with the same radical with the index. Okay, then let's try example 1. Okay, 75. Okay, this is square root. Square root. If the radicand is a square, then you can take this base out. And if the radicand is negative 3 squared, and this is positive x, negative 3 squared is positive, so we can take this negative 3 out, but we have to make it positive. Just like this. Put the absolute value, so that the answer is 3. So we will make the radicand 75 as a product of squares. Then 75 is like, it's a 25 times 3, right? 25 times 3. Now 20 times, yes, 25 times 3. Then 25 is, we can separate 25 and 3. So the square root of 25 is what? 5. And then square root of 3 stays inside. Or from here, you can do this way. Square root of 25 is 5 squared times 3. Then you can take the base 5 out. 5 square root of 3. Because the base 5 has exponent 2. How about 72? Okay, 72 is, okay, let's separate the 72 as a product. The 72 is 36 times 2, right? 36 times 2. How did you get 36? Okay, let's divide 72. Use tree method. So 72 is, if we are not sure, we can start from 2. 2 times 36. 36 is 6 times 6. Right? 6 times 6. This is 6 times 6, so 6 squared. So this is 36 times 2. Then 36 is, you can separate 36 and 2. Then 30 square root of 36 is 6 square root of 2. Okay, how about next one? Okay, 162. Okay, 162 is 91 times 2 actually. If you're not sure, then we can make a tree to find factors. You can start with 2, then what? 81. And 81 is 9 times 9. So that is 9 squared. So 162 is 81 times 2. And 81 is 9 squared times 2. Okay, in this case, we don't have to separate the factors because you can just take this 9 out because 9 has power 2, exponents 2. So you can just take the base 9 out, then square root of 2. The square root of 2 does not have power 2, so stay there. Okay, how about example 2? Same thing. Okay, 25 is what? 25 is 5 squared and x squared. So you can separate. If you want to separate the factors, then you can do this way: 5 squared times square root of x squared. Then square root of 5 squared is 5. How about x squared? The x has power 2, and that is m as the index, but the index is even. Index is even, then what happens? Just like this. If the index is even, and you have something power, and the base is negative, then what do? Make the base positive. So we don't know what this x. X can be positive number or negative number. So we can take this base out, but make sure you change it to the positive number. So we gotta put the absolute value. Okay, absolute value is important. Okay, so even square root of x squared. This is even, index is even, then this is equal to what? X to the nth power, let's say nth power. So this power is m as the index. Then we have to make x positive, absolute value of x. Okay. Okay, let's do the next one. Okay, 12 is 4 times 3. 4 times 3. And then x cubed is, why don't we make this one as a product of squares? So x cubed is x squared times x. And then square root of 4 is 2 squared. This is 2 squared. Okay, let me write it as 2 squared times 3 times x squared times x. Then from here, these 2 can get out. And 3 stays inside. How about this x? You can take that x out. So we can put absolute value of x. And then square root of, what's inside? 3 and x. 3 and x stays inside. Okay, let's try the next one. Okay, 144 is 12 squared. 144 is 12 squared. And x to the fourth power is what? X squared. 4 is 2 times 2, so we can write it as x squared squared. So the number 12 squared, from this factor 12 squared, we can take the base 12 out because the power is 2, same as the index. And then x squared, we can take this x squared out. But in this case, you don't have to put absolute value of x squared because x squared is always positive. X squared is always positive, so you don't have to put the absolute value symbol. So that is okay. Just write x squared. Okay, 72. 72 is what? 36 times 2, right? 36 times 2 is 72. So 36 is 6 squared times 2. And then x cubed is what? X squared times x. Then y squared. Okay, so that is equal to 6 squared, so take 6 out, and x squared, so from here we can take x out, and we can make it an absolute value like this. And then square root of, okay, here is y. So you can take this y out. Take the y out, but make sure you put the absolute value symbol. The square root of, what's inside the square root? Okay, 2 remains inside the square root, and then x, 2x. Okay, so this is the x, 6 times y, and y is an absolute value. How about x? Should we put the x? Well, if this is a real number, if this is a real number, and then you can take this. I think this is okay. And if this is a real number, then this is fine. Okay, in this case, example 2. Okay, let's say the radicand. This is a real number. This is a real number. And then x is what? X cannot be negative because x is negative. Then this is. Oh, sorry, x is fine. So x can be a positive number or a negative number, it doesn't matter. So we can take this x, this x squared becomes what? You can take this x out. So if this is a real number, the index is even, so the inside is positive, so x cannot be a negative. If x is negative, then this radicand becomes negative, then this is not a real number. So if we assume that this is a real number, then x has to be positive number. So in that case, you don't have to put the absolute value on this x, because x is always positive in this case. So that we need only the absolute value of y. Because, square root of x cubed. If this is real, then this cannot be a 0. It cannot be a negative number. X cubed cannot be a negative number. It has to be a positive number. So x has to be x is also always greater than or equal to 0. So in this case, we don't have to put an absolute value. But absolute value is okay, but in this case, actually we don't need it. Okay, how about b? Still b is the same. This is x cubed. If the radicand is a real number, this is a real number, then x has to be a positive number. So in this case, you don't have to put absolute value, just x is fine. X is fine, because we know that x is a positive number. So taking the absolute value is okay, but we don't need it. Okay, this exercise, the index is 3. So let's try to make cube for the radicand. So 40 is what? 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So 40 is 2 cubed times 5. So cube root of 2 cubed times 5. 8 times 5, right? 8 times 5, and 8 is 2 cubed. And then this 2 cubed, if you separate it, it looks like this: cube root of 2 cubed and cube root of 5. So the cube root of 2 cubed is what? Just 2, right? 2. And the right side is then this is, 5 stays inside because 5 does not have a cube, so stays inside the cube root. Okay, how about the next one? This is the fourth root. Fourth root. So why don't we make x fifth to a product of fourth root? So x to the fourth power. So x to the fourth power times x is x to the fifth power. And then this space can get out from the fourth root, because fourth root of x to the fourth power times fourth root of x. We can separate the radicand. Then from the first radical, that is x times fourth root of x squared, fourth root of x. Okay, in this case, should we put the absolute value symbol? Well, actually, we don't need it, because if this is a real number, then already this is positive. Alright, x to the fifth power is greater than or equal to 0. This implies that x is greater than or equal to 0. So we don't have to put absolute value symbol for this x. Let's do some exercise. Okay, number 16 is square root of 100x squared. The index is even. Okay, keep in mind that index is even. Then 100 is 10 squared x squared. So if the radican has power 2, then we can take the base out. Make sure the base has to be positive. So 10 is already positive, so take the base 10 out. How about x? We can take this x out, but make it absolute value. Okay, and next one, 18. 18 is 64. This is square root, so let's make a square. So 64 is 8 squared. And then x cubed. X cubed is what? X squared times x. X squared times x. So we can take the base out, so 8 can get out, and x can get out. And then square root of x. Okay, for this, should we put the absolute value symbol? Well, actually you have to put the absolute value, but in this case, if the square root is positive, then this x should not be absolute value, but absolute value is okay, still fine, to be safe. Okay, 32 is what? Okay, 16 times 2, right? 16 times 2. Okay, if you are not sure, then you can just separate it using the smallest number, 2 times 16, and 16 is what? 4 times 4. So this is 16 times 2, 16 times 2 times x. Then 16 is square root of 4 squared, 2, and x. So 4 has a power 2, so take 4 out, and then 2 and 4, these two factors does not have power 2, so stays inside the radical symbol. Okay, number 24. 125 is 5 times. Okay, 125 is what? 5 times 25, and 25 is 5 times 5, so 5 cubed. So let's make 5 cubed, but we will try to make square because this is the square root, the index is 2. So let's make radicand as a product of squares. So 125 is 5 cubed, 5 cubed. So 5 cubed is 5 squared times 5. And u to the fourth power is 4 is 2 times 2. So we can make it u squared and then raised to the second power. How about v to the sixth power? The sixth power exponent 6 is 3 times 2. So we can make it v cubed raised to the second power. So the exponent is 3 times 2 is 6. Okay, then we can take all the factors, the base of the exponential forms that has power 2. So we can take this 5 out. And then u squared, we can take this u squared out. Then we don't have to put absolute value because u squared is already positive. And then v cubed. Okay, you can take the v cubed out, but if v is negative, then this result is negative. So we have to make it absolute value to make it positive. And then other stays inside. So 5 stays inside. Okay, number 34. Okay, this is the fourth root. So let's make it x to the 14th to a product of exponential forms with power 2, power 4. So 14 is what? 14 is 4 times 3, right? 4 times 3 is 12 and x squared. So this is the fourth root. So we can take all these x's out. So there will be x cubed square root of x squared. Okay, and then what do? Make this one positive. make this one positive. So put absolute value symbol. Okay, let's try next examples. Okay, for this example, the index is 5 and 3. They are odd index. So when we take the base out, we don't have to put absolute value. Okay, so let's find, since the first one is the fifth, the index is 5, we will try to make this number to the fifth power, something to the fifth power. So let's find factors. So let's start with 2, because this is the even number. Then 243. And this is divisible by 3, right? Divisible by 3, because how do we know if this is divisible by 3? Add each digit, 2, 4, 3. Add 2, 4, 3. And if the sum is divisible by 3, then this whole number is divisible by 3. So 2 plus 4 is 6. 6 plus 3 is 9. And 9 is divisible by 3. So this is definitely divisible by 3. So let's divide this by 3. Then 3 times what is 243? 81. And 81 is 3 times 27. 27 is 2 times 9. 9 is 3 times 3. 27 is 3 times 9, right? So in this case, since the index is 5, we will try to make something to the fifth power. So let's check the number of factors of 3. 1, 2, 3, 4, 5. So there are 5 of them. So we can write the number 486 as 3 to the fifth power times 2. And then x seventh is what? X to the fifth power times x squared. Okay. So from here we can take the base 3 out, because 3 has the power 5, same as the index. And then we can take this x out, because this x has power exponent 5. And all those factors that does not have power 5 remains inside, to x squared. Okay, how about this one? The next one. Okay, the index is 3, so let's make something to the third power. So 128 is, okay, we can start with 2, then 64. 64 is, you can start with 2, it's fine. 2 times 32, then 2 times 16, 2 times 8, 2 times 4, 2 times 2. So we can make it 2 cubed times 2. And actually from this one, this is 4 squared. But 4 cubed, right? 4 cubed. So that is okay. We can use 2 cubed. So cube root of 2 cubed, because here's 1 cubed, 2 cubed, times 2 times x cubed. And then y to the fifth power, it can be written as a product of y cubed times y squared. Okay, erase this one. Alright, then this base 2 can get out. This one also can get out. And this 2 stays there. And 3 gets out. This x out and y out. And other stays inside. So 2 stays inside and y squared stays inside. Because y squared, this is not enough. We must have cube. So the exponent is not greater than or equal to 3, so just leave it inside. So finally, 2 times 2 is 4 x, y, cube root of 2y squared. Okay, in this example 5, okay, this is a quotient. So if it's a quotient, then you can put them you can separate the numerator and the denominator. Cube root of 81 over, so square root of 81 over square root of 25. Then 81 is 9 squared. So square root of 9 squared divided by square root of 25 is 5 squared. So 9 over 5. Or this is or the expression is same as 81. 81 is 9 squared. 25 is 5 squared. So we can make it as 9 over 5 squared. Then you can write 9 over 5 directly. Still okay. Okay, the next one is, this is square root. So 56 is not, we cannot write it as a square. So in that case, we can put the numerator and the denominator together. So let's see what happens together. Since we can separate the fractions with the same radical, we can separate it, or you can combine it. So we can combine the numerator and denominator together with the square root. So that can be 56x squared over 8. This is okay. Then we can reduce 56 and 8. So 56 divided by 8 is 7. Then here's 7x squared. Then 7 stays inside, and x squared, from this x squared, x can get out. And then since the index is even, square root index is even, so make sure to make the base positive, square root of 7. Okay. Okay, example 6. Okay, there's a negative sign, so make sure the negative sign stays outside. And the index is cube root, so we can take the base out without making positive. So let's change the numerator and the denominator. Separate. So cube root of y to the 5th power. Y to the 5th power is y cubed times y squared over. The denominator is cube root of 27. Okay, 27 is 3 cubed and x cubed. The negative. The numerator is, okay, we can take the base y out because the exponent is 3, same as the index. And then y squared stays inside because the exponent is not 3, it's less than 3. Okay, from the denominator, take this 3 out. And then also x out. Okay, that's it. Okay, let's do some exercise also. Okay, number 38 is the index is 4, so let's try to make inside a product of some, okay, 4th power to some factors. Okay, 160. Okay, let's go from 160. Let's find the factors. Separate this one into factors. So 2 times 80. Okay, start with 2, still okay. And 8 is 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Okay, so we need 4th power. So let's put 4, 2. I got 2 fours. Okay, so this is 2 to, okay, 160 is a product of 2 to the 4th power, and 2 and 5. 2 and 5, so we can just multiply these two, which is 10. And next to the 6th power is, okay, 6 is 4 plus 2, so x to the 4th power multiplied by x squared. So 4 plus 2 is 6. And then take all base that has the exponent 4 out. So 2 out. How about this one? Yes, we need to take this x out because the exponent is 4, same as the index. So take x out. Okay, make sure you put the absolute value because the index is even. And then other factors stays inside. So 4th root of 10 stays inside and x squared stays inside. So 10x squared. Okay. All right, next one. Okay, the index is 3, odd index. So we don't have to put the absolute values once we take some factor out. So cube root of, okay, let's separate the numerator and the denominator. And 16 is 8 times 2. 8 times 2, and 8 is 2 cubed. Okay, 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. So you can write it as 2 cubed times 2. And z cubed stays there. The denominator is cube root of y to the 6th power. Okay, 6 is 3 plus 3, or y cubed squared. 6 is 3 times 2, so we can write it as this, or y cubed times y cubed. So this is equal to, okay, from the numerator we can take 2 out, z out, then cube root of what? 2 stays inside. And from the denominator we can take this base y cubed out. Okay. Okay, the radical expression is simplified if these three conditions satisfies. So for example, number 1 is all nth powered factors should be removed. Removed from each radical, removed from radical. Okay, that means, okay, let me write it from radical. From radical. Okay, this means, let's say here's a radical, cube root of x to the 4th power. Then here is nth power factor. So since the index is 3, we separate this 4th power to cube. Then finally we can take this x out. So cube root of x. So this one, this nth power factor has been removed. It's simplified like this, so that this factor, the exponent of this nth power factor, is less than the index. Okay, how about number 2? No radical contains fraction. So that means here is a square root, and the radicand, if the radicand is a fraction, something like this, a over b, then this is not simplified yet. Not simplified in this case, because the radicand is a fraction. Because if this is fraction, then you can separate square root of a and square root of b. And then number 3. Number 3 means no denominator of a fraction contains radical. So once we separate the numerator and denominator using the same radical, there is a radical in the denominator. So this fraction should not contain the radical in the denominator. So this is not simplified yet. Even this one is not yet. So denominator should not contain radical. Okay. So in this case, what do we do? In this case, we do rationalizing the denominator method to remove the square root from the denominator. So we will do it later. So radical expression is simplified if the radicand is not a fraction and the fraction does not contain radical expression in the denominator. Okay, so let's simplify some examples. Okay, this example is, we will simplify these radical expressions using rationalize the denominators. Okay, this means, okay, we don't allow fractions in the radical. So we have to separate the numerator and denominator with the same radical, square root. And then we don't allow square root of 5 in the denominator. So how do we get rid of this one? Multiply both top and bottom by square root of 5. The same thing, the square root of 5. Because, do you remember, square root of 5 times square root of 5 is 5, right? Because square root of 5 squared, so that is 5. So multiply both top and bottom by square root of 5. Then the numerator is square root of 3 times 5. Square root of 3 times 5. And the denominator is 5 times 5 is 25. So let's change this one into 5. So square root of 5 times square root of 5 is 5. So finally, square root of 15 over 5. Okay, this is called rationalizing the denominator. So whenever we have something like this, 3 and square root of, let's say 7, then multiply both top and bottom by square root of 7. So square root of 7 times square root of 7 is 7. The numerator is square root of 3 times 7 is 21. Okay, how about this? Letter B is the denominator is cube root. So we don't allow radical in the denominator. So we can rewrite, we can multiply. Let me write this one again. Okay, cube root. So we will try to make inside cube of some factors. So 9 is 3 squared. 9 is 3 squared. And then from here, look at this, the radical in this denominator. The radical is 3 squared. The index is 3. So if we have one more cube root of 3, then this will be 3 cubed. So why don't we multiply, okay, use the same cube root of 3. Then the radical will be 3 squared times 3 is 3 cubed. Okay, so that is 4 times, you can multiply both top and bottom by cube root of 3. Then the numerator is 4 times cube root of 3. And the denominator is what? Cube root of 3 squared times 3 is 3 cubed. So finally the denominator is 3. The numerator is still 4 times cube root of 3. Okay. So, okay, just like this. Let's say, okay, 2 over, okay, fourth root of, let's say, x. Then what do we multiply both top and bottom? We gotta multiply fourth root of x cubed. Fourth root of x cubed. Because this x times x cubed has to be x to the fourth power. Okay, the exponent of these two product has to be same as the index. So since this one, the index is the power is 1, we need 3 more, right? 3 more. So multiply the top and bottom by fourth root of x cubed. Okay, how about next one? Okay, this is equal to 8 over 3. And 18 is 9 times 2. Okay, 9 times 2. So 9 is 3 squared times 2. 3 squared times 2. Alright, in this case, what do we need? Okay, 3 squared, we can take the 3 out. 3 times, okay, for this one. Since this is square root, we can take this 3 out. And then 2 stays inside. Then 8 over 9 times square root of 2. Okay, since the denominator contains square root of 2, the radical, so we gotta multiply both top and bottom by what? Square root, right? Square root of 2. Square root of 2. Then the numerator is 8 square root of 2 over 9 times. Square root of 2 times square root of 2 is what? 2. Okay, so we can cancel out 4 and 2, and reduce 8 and 2. Then 4 square root of 2 over 9. Okay. So rationalizing the denominator is very useful to remove radicals from the denominator. So what we have to do is multiply both numerator and denominator by radical, and that radical has to be the exponent of the radicand has to be same as the index. Okay, in this example, let's rationalize the denominator. So, okay, before we separate the numerator and denominator, let's simplify 8 and 12. 8 and 12. So 8, okay, we can reduce 8 and 12, so divide each by 4. Then 2x over 12 divided by 4 is 3. Y to the 5th power. Okay, and then separate the numerator. 3y to the 5th power. And since this is a square root, why don't we make it y squared times y? Okay, so that we can take y's out. So take this y out, then y times y is y squared, square root of 3y. Okay, now what's next? Rationalize the denominator. So since the denominator is square root, we will make a square for each factor of this 3 and y. So we got to multiply square root of what? 3y. Because 3 times 3 is 3 squared, y times y is y squared. So then multiply the numerator by 3y. Then finally, the bottom is y squared times 3y. And the numerator is what? Square root of 6xy. So this is equal to square root of 6xy over 3y cubed. Okay, for this, look at this. This is square root of y squared. So we can take this y out, but since this is a square root, even index, we gotta put absolute value over there. Okay, so the denominator is y squared times y squared times y, and then there will be y cubed. So it's gotta be a positive, so we can make this y cubed absolute value symbol. Okay, so a little bit confused because y squared is, we can take y out, but since the index is even, make the base positive. So put the absolute value on this y. So y squared times y is y cubed. We have to make it positive. So put absolute value. Okay, the next one is cube root. So the numerator denominator is, we can just separate it because 54 and 5 we cannot simplify. So separate the numerator, 54 x to the 6th power y cubed. The denominator is cube root of, okay, it's gotta be same index, cube root of 5 z squared. Okay, then the 54 is, okay, let's check 54. Let's find the product. We gotta make a cube. So 54 is 2 times 27. Okay, 27 is 3 cubes. So 3 times 9, 3 times 3. So we can write it as 3 cubed times 2. So cube root of 2 times, okay, 3 cubed times 2. And x to the 6th power. X to the 6th power is 6 is 3 times 2. So let's make it 2 times 3. 6 is 2 times 3. So why don't we make it x squared and 3rd power. So 2 times 3 is 6. And the y cubed over. The denominator is cube root of 5z squared. So this is equal to, the numerator is, we can take 3 out, and x squared out, y squared out. So 3 out, x squared out, y out. Then which one left? The factor 2 left. Okay, and at the bottom is, the denominator is cube root of 5z squared. Okay, now let's rationalize the denominator. Okay, when we rationalize the denominator, find the factors. How many of the factors should be multiplied? So since this is a cube root, 5, the exponent of 5 is 1, so we need 5 squared. And z is 2, exponent of z is 2, so we need one more z. So multiply cube root of 5 squared z to both top and bottom. Okay, then the numerator is 3x squared y cube root of 2 times 5 squared z is, 5 squared is 25 times 2 is 50 z. Can we make the 50 a product of cubes? No, that's it. And the denominator is what? 5 is already cubed, z is cubed, so we can take 5z out. We can rewrite one more time then. Okay, then this is cube root of what? 5 cubed, z cubed. So 3x squared y cube root of 50z over 5z. Okay, let's do this exercise. Okay, we can separate the numerator and the denominator. Square root of 1 over square root of 5, and square root of 1 is 1 over square root of 5. Okay, we don't allow radical in the denominator, so we can multiply both top and bottom by square root of 5. So the numerator square root of 5, denominator is square root of 5 squared is what? 5. Okay, the next one. Okay, cube root of square root of 9 over cube root of 25. And 25 is, so we have to rationalize the denominator. So 25 is cube root of 5 squared. So what do we need? We need another 5, cube root of 5, because the power is 2, so we need to make it 3, so we need one more 5, cube root of 5, cube root of 5. So the numerator is, okay, this is cube root, so we gotta multiply inside. So cube root of 5 times 4 is 45. And the denominator is what? Cube root of 5 cubed. So the denominator is 5, the numerator is cube root of 45. Okay, next one. Okay, what do we multiply both numerator and the denominator? Okay, we gotta multiply, we have to rationalize the denominator. And this is square root, so we have to make a square for each factor. So 3, we need another 3. We need another c. So it will be 3 squared times c squared. And the numerator is square root of 3c. So that is equal to 2 times square root of 3c. The bottom is what? 3c times 3c is 3 squared. The bottom is 3 squared, c squared. So 3c is the denominator, numerator stays the same. Okay, next one. Okay, for this, the denominator is 3x and square root of x. Since we have a square root of x, why don't we multiply both top and bottom by square root of x? So the numerator square root of x, denominator is what? 3x times square root of x, that is equal to x. So square root of x over 3x squared. Should we? Okay. And the last one. Okay, cube root. And 29 we cannot simplify, so just leave it and then separate numerator and the denominators. Cube root of, okay, 9 is 3 squared and y squared. So in that case, what do we need to multiply? The both numerator and denominator. Okay, the factor 3 has power 2 and even y has power 2. So we need one more 3 and y because the index is 3. So multiply this 3 cube root of what? 3 and y. Cube root of 3 and y. So the numerator is what? 3 times cube root of 20 times 3 is 60 x squared y. The denominator is cube root of what? 3 cubed y cubed. So numerator stays the same, 60 x square root of x squared y, and the bottom is 3y. Can you make this 60 as a product of cubes? No, right now, that's it. Okay, in this example 9, we will use Pythagorean theorem. So Pythagorean theorem is, okay, here is a right triangle. right triangle. Let's say this is the base A and this is height B. Then we can find the hypotenuse. So the relation to these three sides is this. Okay, C squared, the hypotenuse squared is the sum of squares of the other two side lengths, A squared plus B squared. So that C equals square root of A squared plus B squared. Then let's find, okay, the bases are, the two legs are 6 and 9. 6 and 9. Then let's find C. Okay, C is equal to, using the Pythagorean theorem, C square root of A squared plus B squared. And then A is 6, so 6 squared plus 9 squared. Then 36 plus 81. Then 117. So that is square root of 117. And so 117 is that is divisible by 3, right? So 117 is divisible by 3. So 3 times 37. Okay, 3 times 39, right? And 39 is 3 times 13. So since this is square root, you can write it as square root of 3 squared and 13. So that is equal to 3 times square root of 13. So this is the length of the side C.